Hi guys, welcome to this set of videos. What we've been doing here in the last couple of sections is we've been looking at properties of triangles, right? We started by talking about this relationship between the interior angles of a triangle, and then we took a look at the relationship with the exterior angles of a triangle. And then in the last section we talked about the properties of isosceles triangles and the properties of equilateral triangles. And now what we're going to do here in this section, I know sounds kind of like a scary thing, triangle inequalities, what? Triangle, what are you talking about? Actually, it's not that big a deal. What we're really, essentially, here's the gist of what we're going to do. We're going to take a look at the measure of the triangle's sides, right? A triangle has three sides. There are certain side lengths that will work to build a triangle, but there are certain side lengths that will not work, right? If you put certain lengths of sides together, you don't get a triangle. And that's essentially what we're going to be looking at here. If I give you three sides, can you build a triangle out of them or can you not? Let me show you exactly what I mean right here. Actually, before I do that, I apologize, essential question, but that's essentially what I just explained to you. Based on the relationships among the side lengths and the angles, can you build a triangle? What can you tell me about that triangle? Of course, our objective is the stuff that you guys need to know, the stuff we're going to talk about in order to help you answer that question. So now, like I was saying, here we go. Let's just jump right into this. Essentially, here's the way triangle inequalities are going to work. What I've done is I have given you a side, one side of a triangle right here. And I have told you that that length, AB, is equal to 4, right? AB is equal to 4. Now, we're going to get a second side of the triangle, and all I tell you is the second side of the triangle must be 2 inches. So here's what I'm going to do. I'm going to take my compass, okay? I'm going to open that compass to 2 inches. I put it on B, and I draw a circle that has a radius of 2 inches. Now, here's what we can do. It doesn't matter where you put point C. I can put it, in fact, let me draw it in a couple of places. I can put point C right here. That'll be 2 inches. I can put point C over here. It'll still be 2 inches. I could put point C down here. Still 2 inches. Or I could put C, I don't know, let's do one more, maybe right there. Still 2 inches. But please notice what happens. Depending on where I draw the segment BC, depending on where I draw that segment, what does it do? It changes the length of AC, right? If this is segment BC right here, then there's AC. If this is segment BC right here, there's AC. Look at how much longer it is, right? Or right there, AC. Or right here, AC, right? Depending on where I put that segment BC, it's changing the length, right? It's changing the length of this third side. The question is this: are there certain places, are there certain measures, certain lengths of AC that are not allowed, right? These blue lines, right? You can see I've got, each of these is a different length, right? And you can actually see, depending on where I put C on this circle, I could actually get an infinite number of different lengths, right? That blue line could be an infinite number of different lengths. But the question is, are there any lengths that it can't be, that it's not allowed to be? Let me show you right here. Exact same diagram, right? I put C right here. You can see there's side AC. The question is, are there any lengths that AC is not allowed to be? Well, consider this. What if I put C right here? Again, CB is 2 inches. Well, that means AC would also be 2 inches. But does that make a triangle? No, that's not a triangle. That's a line, right? We're making triangles, and that ain't no triangle, it's a line. So here's what I know. I know that the length AC cannot be 2 inches. If AC had a length of 2 inches, I don't have a triangle, I just have a line. No bueno. Let me show you another one. What if I put C right over here? Again, CB, 2 inches. What does that make the length of AC? Well, that would make the length A to C. Remember, AB is 4 inches. BC is 2 inches. 4 plus 2 is 8 inches. Or 8 units. I don't think I said inches. Oh, I did. 4 inches. So it would be 8 inches. But that's not a triangle. Look, that's just a line. We're building triangles, not lines. So I just found another one. AC cannot be 8 inches, right? Because if AC is 2 inches, I don't get a triangle, I get a line. And if AC is 8 inches, I don't get a triangle, I get a line. And that answers our essential question, right? When building a triangle, are there certain side lengths that are not allowed? The answer? Yes. Not all lengths will work. There are certain side lengths that will not build you a triangle. And that's exactly the question that we're going to answer here in the next couple of problems. Let me show you how we're going to do it. The triangle inequality theorem. Here's all it is. You're going to be given 3 side lengths. 3 side lengths, and we're simply going to test and see, do those side lengths work to build a triangle? And the way that you'll know is simply this. It's given to you right here. Very, very simple idea. It's simply this. The sum, adding together any 2 sides. Pick any 2 sides you want to. I can do this side and this side, right? Add them together. I can do this side and this side. Add them together. Last one, I could do this side and this side. Add them together, right? The sum of any 2 side lengths must be greater than the length of the 3rd side. That's why I have this greater than symbol in here, right? Add together any 2 sides. I don't care what 2 sides you pick. Add together any 2 sides. It must be greater than the length of the 3rd side. If it isn't, those lengths will not build a triangle. Let me show you exactly what I mean in a couple of example problems. Boom. I've given you 3 side lengths. 4, 8, and 10. 4, 8, and 10. We want to check and see, are these good for building a triangle or do they not? Real simple idea. Here's the way it's going to work. Remember, you add together any 2 side lengths. If you wanted to, you certainly could. 4 and 8. Draw yourself a picture of the triangle if you wanted to. You certainly could. It doesn't matter, right? The idea is you need to be able to add together any 2 sides. I don't care what 2 sides you add together. It's got to be greater than the length of the 3rd side. So let's just run through it in systematic order and do them all. I could add 4 plus 8. I need that to be greater than 10. I could add 4 plus 10. I need that to be greater than 8. I could add together 8 plus 10. I need that to be greater than 4. I got them all, right? I have 3 sides, and I've taken care of each of my triangle inequalities. 4 plus 8, got to be greater than 10. 4 plus 10, got to be greater than 8. 8 plus 10, add together any 2 sides. Got to be greater than the 3rd side. Now, you solve each of these. If even one of them is false, nothing works. None of them are good. You cannot build a triangle with those side lengths if even one of them turns out to be false. We need all of them to be true. So here we go. Let's see, 4 plus 8, how about 12? Is 12 greater than 10? Check. 4 plus 10 is 14. Is that greater than 8? Check. 8 plus 10 is 18. Is that greater than 4? Check. The conclusion? Yes. These side links will build a triangle. Absolutely. I just did it. Right there. There's your triangle. 4, 8, and 10. It works. Let's try another one. I could do 7 plus 9. It's got to be greater than 18. I could do 9 plus 18. Got to be greater than 7. I could do 7 plus 18. Got to be greater than 9. Those are my 3, right? Add together any 2 sides. All of the inequalities must be true. If even one of these is false, it doesn't work. Let's check them. 7 and 9 is going to be 16. Is 16 greater than 18? Wait, did I do that right? I did. Look at that. Is 16 greater than 18? That is false. No. Okay, I'm going to do the rest of them anyway, but at this point, stop. You can stop. 16 is not greater than 18. That's false. This doesn't work. No, you cannot build a triangle. But I'll do the rest of them because I got them here. Let's see, 9 and 18 would be 27. Is that greater than? It is. 7 and 18 would be 25. Is that greater than 9? Yes, it is. So as you can see here, 2 of them worked. That's why you have to check all 3. You have to check all 3. 2 of them worked, but this one didn't. Because this one didn't, no way. As soon as you get a statement that's not true, those 3 sides won't work. You cannot build a triangle with these 3 sides. Can't do it. I got a couple more for you here. Oh, look at this. I tell you it's an isosceles triangle, right? Isosceles triangle, I want to know, can an isosceles triangle have those particular side links? Put together your inequalities. 5 plus 10 has to be greater than 5. Again, right? 5 plus 10 has to be greater than 5. 5 plus 10, right? That's the other 5. So 5 plus 10. I'm just going to happen to get the same answer twice, but that's okay. And then, 5 plus 5 has to be greater than 10. All right, let's check them. Well, 15 greater than 5? You bet. 5 plus, I get 15 again, greater than 5? You bet. Let's see, then I get 5 plus 5, which is 10. Now, careful here. Is 10 greater than 10? No. 10 is equal to 10. But this doesn't say greater than or equal. This says greater. I need this number to be bigger than 10. And it isn't. It is 10. This is false. As soon as one of them is false, you're done. The answer is no. Those will not work to build a triangle. Can't do it. Keep going. Set them up. 12 plus 4 greater than 7. 12 plus 7 has to be greater than 4. And 7 plus 4 has to be greater than 12. Okay, here we go. 12 and 4, I believe, is 16. Is that greater than 7? You betcha. 12 and 7 would be 19. Is that greater than 4? You betcha. 7 and 4. 7, 10. Ooh, yikes. I put equals, sorry, greater than. Is 11 greater than 12? No siree. That's false, which means no. You cannot build a triangle with those sides. Won't work. Here we go. One more. 24 plus 8 has got to be greater than 30. 30 plus 8 It's got to be greater than 24. And last one, 24 plus 30 has to be greater than 8. Okay, well that last one is easy. 24 and 30, that's 54. That is way bigger than 8, so that one definitely checks out. 30 and 8, right, that's 38. That's a pretty easy one too. 38 is definitely bigger than 24. Here's the one that might cause a problem. Let's see, 24 plus 8. 24 plus 8 gives me, 32. Is 32 bigger than 30? Yes, it is. Which means those side links will work, right? All of them have to check out in order for the sides to work, those links to be possible values for the side links. If even one of them is false, none of them will work. Head on over to the next page of the notes, guys. We'll keep going with this idea of possible values for the links of the sides of a triangle and values for the links of the sides that it can't be, right? What doesn't work. We'll do all that on the next page of the notes. I'll meet you there.